Okay, so welcome to lecture 3, and today we're going to discuss measures of central tendency on grouped data. Okay, so all right, so we have seen how to find the mean. Okay, so we have seen how to find the mean, the mode, the median, standard deviation, variance, and coefficients of variation for ungrouped data. Okay, this was easy because we just had a set of data that was not grouped. Okay, now today we're going to look at how we can find the mean, the mode, the median, the standard deviation, and the variance for grouped data. Okay, so let's have an example. Suppose we have the data set. We have classes. We have 10, but less than okay, so we have 10 but less than 20, 20 but less than 30, 30 but less than 40, 40 but less than 50, 50 but then finally 60 but less than 70. Okay, so those are our classes, and then we have our frequency, which we denote by Fi. Okay, so that is our frequency. And here we have 2, 9, 13, 15, 5, and another 5. Okay, so now suppose these were our classes and their frequencies. How can we find the mean? Remember, when we had ungrouped data, we just used to count, take the values, and add and divide by the total frequency. Okay, so let's have the total frequency here. We're going to find that the total frequency is actually 49. Okay, so to find the mean, the mean, which is denoted by X bar, is just equal to the sum of the frequency times the midpoints over N, which is the total frequency. So Fi there is the frequency here we're just saying F1 is the frequency of the first class, F2 will be the frequency of the second class. Then XI is the midpoint of the ith class. Okay, so Xi is the frequency of the ith class, and N is the total frequency. Or the sample size. Okay, so that's how we get the mean. So from our previous example, that means that we have our frequencies. We need to find the midpoint. That is the Xi. Okay, so to find the midpoint, I already showed you how to find the midpoint. You just get, for the first class, you have 10 plus 20 divided by 2. Okay, so that's a 15. Then 20 plus 30 divided by 2, you have 25. 30 plus 40 divided by 2, you have 35. Then there you have 45, 55, and finally we have 65. Okay, so remember from the previous from the formula, we need to multiply Fi by Xi and then get the sum. Therefore, we're going to have another column of Fi multiplied by Xi. So that is 2 for the first class, 2 multiplied by 15, and that is the 30. For the second class, we get 225. For the third class, we get 455. The fourth class, we have 675. Then 275, and finally we have 325. Then we need to get the sum, which is just the total. So add those numbers and you have 1985. Okay, so then let's find our mean. So our mean, which is X bar, is equals to sum of Fi Xi over n. And there we found the sum, which is just the total, is 1985 over n, which is the total frequency, is 49. And that gives us 40.51. Okay, so that is our mean. Now we move to the next thing. Okay, so we move to the mode. Remember, we said that the mode is the value that appears more in the data set, the value that has the highest frequency in the data set. So for grouped data, the mode is just the class, okay. Okay, so to find the mode, we need to identify the model class. So the model class is just the class with the highest frequency. So that is what we need to do for us to find the mode for ungrouped data. First, identify the model class. Okay. Now the formula for the mode is given by mode is equals to the lower limit plus open brackets frequency of the model class minus frequency of the class before the model class over frequency of the model class minus frequency of the class before plus frequency of the model class minus frequency of the class after. Okay, so maybe let's just define those terms. L is equals to lower limit okay, so the model class, I'll shorten it as MC, model class. So lower limit of the model class, FM is equals to the frequency of the model class Fm minus 1 is equals to the frequency before model class. Oh, actually the formula, we need to multiply that with the widget. Okay, so then our Fm plus 1 is just frequency after model class. Okay, W is the class widget. So those are the terms we find in the mode for ungrouped data. First, identify the model class, which is the class with the highest frequency. So from our to find the mode in this example, we first have to find the model class, which is just the class with the highest frequency. And here the class with the highest frequency is the class between 40 and 50 because it has a frequency of 15. So that is our model class. Therefore, so we need to know the frequency of the model class, which is 15. The lower limit is just this value, the one that we have talked about in the past. So a lower limit will be 40 in this case. And the frequency of the model class, which is FM, is 15. The frequency before is 13. The frequency after the model class is 5. The class widget. So to find the class widget, just when you're given a table, you just get any two lower limits. Say 10 and 20. Find the difference. So that is 20 minus 10, you will find a 10. Or you can get any two lower limits as in 30 and 40. Get the difference. That is 40 minus 30 to give you 10. You can get as well any two upper limits, like 50 and 40 there. You're going to find that the difference is 10. So subtract the smaller value from the bigger value. So that's how you find the class width when you have been given a table. So from here, it is 10. Therefore, we can now find our mode. So, the mode here just equals to L plus, open bracket, frequency of the model class minus frequency before, over frequency of the model class minus frequency before, plus frequency after. Okay, so that is the frequency of the model class minus frequency after the model class times the class width. Okay, so let us now replace. We just found that that was 40 plus, open bracket, 15 minus 13 over 15 minus 13 plus 15 minus 5 times 10. So this will give us 40 plus 2 over 2 plus 10 times 10. This will give us 41 points. So you have to be careful on the operations. So you first begin with what is in the bracket, find it, multiply by 10. After that you add to 40. So that will be, the answer will be 40 plus 1.667, which is just equal to 40. Which just gives you 41.667. So you actually know from the model class that your mode should be between 40 and 50. So that is the class that contains the model class. Okay, so we move on. Okay, so we move on now to the median. Now, you should remember the definition of the median. This is just the value that divides the data set into halves. Okay, the value that divides the data set into halves. Alright, so in finding the median, we have to make sure that, remember, that data set has to be ordered. So it has to be from the smallest to the biggest. Okay, now to find the median, we have the formula. Median is just the lower limit plus n over 2 minus the cumulative frequency before the median class over the frequency of the median class times class width. So the class which contains the value that divides the data set into halves is known as the median class. Okay, so to find this value, what you have to do is get your n and divide it by 2. So which is our total number is 49, then you divide by 2. So the value that is on the middle is 24.5. 5. And this is approximately what? 25. So we check in our data set in which class 25 falls. Okay, so actually where we find the 25th value. Okay, so let's go back to our data set. Okay, so this is our data set. Remember, it starts from 10 and it goes up to 70. So we assume that this data has been sorted. Okay, so this data has been sorted. So we want to find where the class in which we can find the 25th value. So we therefore find the cumulative frequency. So the cumulative frequency for the first class is 2, 11, 24, 39, 44, and finally 49. Okay, and finally 49. So okay, so therefore, look at our cumulative frequencies. We can therefore find the position of the 25th value. Okay, so there in the first class we just have 2 values. In the second class we just have 11. In the third class we just have 24 values. Okay, so the 25th position or the 25th value will fall into the 4th class. Okay, and this class becomes our median class, and this is the class between 40 and 50. So first identify your median class. Divide your n by 2, round it off, which is our value was 24.5, round it off, it became 25. So you now find the position or you find where that value would fall using the cumulative frequencies. Up to the third class, we just have 24 values. Okay, so in the fourth class, that's where you find the 25th value. So the median falls in this value because in this class. So in this class, we find the value that divides the data set in halves. So we take note of the class, which is 40 to 50. Now you have to remember from our formula, we need to find the frequency of the median class. Okay, the frequency of the median class as well as the cumulative frequency before. So the frequency of the median class is 50 and the cumulative frequency before the median class is 24. The class width still remains a 10. Okay, so actually, I think I didn't identify the terms. So L there is just the lower limit of the median class. CF M minus 1 is the cumulative frequency. Of the median class. FM is the frequency of the median class. Okay, so those are the terms. Now remember, we have already identified the terms. So therefore, our L is 40. So here we can just put our L is 40. Frequency of the median class is 15. Cumulative frequency before the median class is 24. N over 2 is 24.2. 0.5. The class we did is 10. Now, when you are putting the N over 2, please do not put the approximated value. You have to put the one that you originally found, which was 24.5. So, remember, our median is just L plus N over 2 minus cumulative frequency before over frequency of the median class multiplied by the class we did. So this gives us 40 plus 24.5 minus 24 over 15 multiplied by 10. Gives us 40 plus 0.0333 times 10, 40, 0.33. This gives us 40.33. Okay, so that is our mode, our median. Alright, then we now go to measures of dispersion, and we're going to find the variance. So variance, which is represented by S squared. So I'll give you two formulas. You can use whichever you're comfortable with. So we have the first one, which is sum of xi minus x bar squared multiplied by the frequency over n minus 1. Or s squared is equal to the sum of xi fi squared minus sum of fi xi squared over n or over n minus 1. Okay, so these are the two formulas. So you just follow the formula. The first one has xi minus the mean. Then you multiply by the frequency. Then divide by n minus 1. Okay, so from the example, you're going to see how to use all of both the formulas. So from our example, we first have, we know our mean is 40.51. Then we have our classes. $10, but less than 20, 20, but less than 30, 30, but less than 40, 40, 50, 50, then finally we have 60, 70. Okay, so we had our Fi, which was 2, 9, 18, 15, 5, 5. Then we have our Xi. We have 15, 25, 35, 45, 55, 65. So from the formula, we need to find the term xi minus x bar squared, then multiply by fi. Okay. So then we're going to first start by having xi minus x bar, that column. So we are just subtracting the mean from the midpoints. Subtract the mean from the midpoints. So the first one we have minus 25.51, minus 15.51, minus 5.51, then we have 4.49, 14.49, then we have 24.49. Okay, then we are going to have xi minus x bar squared. So that is just squaring the values that we have found there. So we paste our 650.76, then 240.56, 30.36, 20.16, 209.96, and 599.76. Okay, then finally we have to get the midpoint, subtract by a squared, then multiply by fi. Remember, we are looking for the sum. So there we have 1301.52, 2165.04, 394.68, 302.40, 1049.80, and 2998.80. So get the sum there. You're going to find 8212.24. Okay. So remember, we're looking for this sum. That is why we have done all this. Okay. So now we can now replace in the formula. Okay, so in the formula, our variance is just sum of xi minus x bar squared multiplied by the frequency over n minus 1. And this value is just 8212.24 over 49 minus 1. 49 minus 1, which is just 171.088. Okay, so that is our variance. To find the standard deviation, we just square root the variance. So which is just square root of 171.088. And this gives us 13.08. So the last thing that we're going to do is find the coefficient of variation. CV. Okay. So now the coefficient of variation we know is given by standard deviation over the mean times 100%. So that gives you, we know our standard deviation is 13.08 divided by 40.51 times 100%, and that gives us 32.29%. Okay, so we're going to end here with the first example, and we're going to continue with the second example in the next slides. Thank you.